Hey guys, so today we're going to start Chapter 7, Organic Nomenclature. So in this class, really the only organic chemistry that we deal with is the nomenclature, so the naming compounds. So we learn how to name a very small portion of organic compounds and then how to go from the name to structures for a very small portion of organic compounds. If you continue to my senior level class, we'll spend about a whole 9 weeks on organic reactions. If you go to college and study chemistry or biology, you'll spend a couple of years talking about organic chemistry. So let's go ahead and jump in and start learning how to name some organic compounds. So first we need to well define what organic chemistry even is. So in chemistry, the term organic refers to anything containing carbon. Okay, so any molecule that we deal with that has a carbon in it, for the sake of this, we'll consider it organic. So carbon forms 3 types of bonds to itself. So it covalently bonds to itself with a single bond, a double bond, or a triple bond. And carbon also very commonly bonds to hydrogen, oxygen, nitrogen, and the halogens. So to begin naming carbon-containing compounds, instead of using the prefixes that we learn when naming covalent compounds, the mono, di, tri, tetra, and so forth, we have a different set of prefixes that allow us to tell in a name how many carbon atoms we have in a molecule. So we'll go ahead and list the prefixes out here. I'm going to make 2 columns. And so for 1 carbon, we use the prefix methyl. For our 2 carbons, we would say ethyl. 3 carbons would be propyl. 4 would be butyl. So those are the 4 really new ones you need to learn: the methyl, ethyl, propyl, and butyl. From here forward is kind of what you would expect. Hexyl, excuse me, sorry, I got ahead of myself. Pentyl would be 5. Hexyl would be 6. 7, you will see heptyl, H-E-P-T-Y-L, or septyl. 8, you'll see octyl. 9, you'll see nonyl. And 10, you'll see decyl. So those are the prefixes that we will use to denote how many carbons we have in our molecule that we're naming. So before we can start learning some rules for naming compounds, we need to figure out how to draw these compounds. Okay? So rather than the basic Lewis structures that we learned in Chapter 5, we're going to use a little more simplified method to show bonds in an organic molecule. So let's just look at a molecule here. Okay. So don't worry about what this molecule is, just kind of go ahead and sketch it out like I have. You'll notice that every carbon in this molecule has 4 bonds, okay? So you can make a note. So carbon almost always has 4 bonds. And that happens so often that we actually make the assumption that carbon will always have 4 bonds. There are situations like carbanions and carbenes that you might discuss in college where this doesn't happen, but for this level, of course, we can assume that carbon always has 4 bonds. Okay? So if it always has 4 bonds, we can use this to kind of simplify our structure. So carbon always has 4 bonds, and if a bond is not shown, we assume it is to hydrogen. Okay? So this is a very, very simple organic molecule. It's one of the most simple molecules you'll see. But it took up a lot of space to write it, and it took a while. So we can condense this one step. We could write CH3, CH2, CH3. Okay? So that's just the simplified form of this, but it's still a lot of work. So the form that we want to use, we'll call it the stick model. So this is how we would write the molecule above. Okay? So let's look at what these stick models are really telling us. So you can write this out in words if you prefer. The end of every line okay, as well as every corner is a carbon atom. Okay, so there we have 3 carbon atoms. Up here we have 3 carbon atoms. And we said that every carbon has 4 bonds, and if we don't show a bond, it's the hydrogen. So this carbon right here is bonded to one other carbon, okay, so it has 1 bond that's shown. But we're also not showing 3 bonds to hydrogen. Okay? So this carbon right here is bonded to 2 other carbons. So it already has 2 bonds, but we're not showing that it's bonded to 2 other hydrogens. And then this carbon down here, it's already bonded to 1 other carbon, but we're not showing that it's bonded to 3 other hydrogens. Okay, so instead, I kind of drew this out to show you what was going on here, but you would simply see this structure written like this right here, and you would know just based on this that the formula for this is C3, and you could say there are 1, 2, 3, 4, 5, 6, 7, 8. So if there's C3H8, and you have to go through in your mind and say there are 3 hydrogens here, 2 hydrogens here, 3 hydrogens here. So if you need to draw that out for right now, that's perfectly okay. So let's go ahead and look at another one. So what I want you to do is go ahead and draw that, and then write the molecular formula for this. Okay? Let's go ahead and do it together. Let's count the carbons. 1 carbon, 2 carbons, 3 carbons, 4 carbons, 5 carbons, 6 carbons. So we have C6. Now I'm going to write in the number of hydrogens that are bonded to each carbon. So this carbon right here already has 1 bond shown. So it has to have 3 other bonds that we're not seeing. So it has to be bonded to 3 other hydrogens. This carbon right here already has 2 bonds. So there's 2 bonds that we're not seeing. So it's bonded to 2 other hydrogens. The same for this carbon, and this carbon. So this carbon on the end here is only bonded to 1 other carbon. So there are 3 hydrogens that we're not seeing. So we go back and add it up, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I have C6H14 is my molecular formula there. Okay, so let's try another one. Let's look at, what if I had this? Okay, so you'll find that cyclic structures, structures with rings, are very common in organic chemistry. So let's look at this one. This one has 1, 2, 3, 4, 5, 6 carbons. It is the same number of carbons as the structure above. And then let's go look at each carbon and count the number of hydrogens. So this carbon already has 2 bonds, so it has to have 2 more hydrogens. There are 2 hydrogens here, 2 hydrogens here, 2 hydrogens here, 2 hydrogens here, 2 hydrogens there. Okay. So I counted up, and there are a total of 12 hydrogens. Okay. So this right here is the exact same thing as doing this. Those are identical there. It's just this structure with the stick model is significantly easier to look at. Okay, we can visualize that a lot easier. So let's look at 1 or 2 more. So here I have a double bond between 2 carbons. Okay, so let's write the formula for this. All right, 1, 2, 3, 4 carbons. So I have C4. Now I need to go back and count up the number of hydrogens on every atom. So here there are 3. Here I already have 1, 2, 3 bonds, so there's only 1 hydrogen there. Here I already have 1, 2, 3 bonds, so there's only 1 hydrogen here. Here I have 3 hydrogens, 3 other bonds. Okay? So I add that up, and my total number is 8. Okay? So using this kind of stick model, everything that's not a carbon or a hydrogen I would explicitly show. So if I had an bonded to an H there. Okay, so I would explicitly show the oxygen and the hydrogen. So let's write this formula. So I have 1, 2, 3 carbons. Then I have 3 hydrogens here. I have 3 hydrogens here. I have 1 hydrogen there. Then I can't forget about this one up here. So I have 3, 6, 7, 8. H8O. So it's standard convention to write carbon first, then hydrogen, then we go oxygen, nitrogen, and then down through the alphabet. So let's look at 1 or 2 more of these. So go ahead and for each of these, you can pause the video and try and write the molecular formula for these 2 compounds here. Okay, so now let's go through them together. So this one on top has 1, 2, 3, 4, 5, 6 carbons. So carbon is 6. Here there are 3 hydrogens. Here there are 2. Here there are 3. Here there are 1. Here there are 2. Here there's 3. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So C6H14. So this structure down here I have 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6 carbons. So C6. Then I have 3 hydrogens, 1 hydrogen, 2 hydrogens. Here, there's already 1, 2, 3 bonds to that carbon, so there's only 1 hydrogen. In this carbon, there are already 2 bonds, so there's only there's 2 hydrogens there, because I need a total of 4 bonds. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? So I have C6H12. So now, hopefully you have a pretty firm grasp of being able to look at these stick structures and being able to tell me how many carbons there are, how many hydrogens there are, and how many other molecules there are. So now we'll go ahead and apply this into naming some organic compounds.